Good day, and welcome to the National Tutoring Campaign. My name is Nonkululeko Matondo. I am your grade 11 physical sciences teacher. I hope that everybody is having a great day and ready to do some physical sciences. Just reminding you guys that we are busy doing our term 3 work. We are busy doing our term 3 work, and we have started with our chemistry this week. From last week when we were doing and this week we are starting now with the chemistry part. We did electrical changes and we did electromagnetism on the previous weeks, and now we are on energy and chemical changes. Okay, just an overview. What we're going to do today, we're going to explain the energy change in chemical reactions. We're going to define the exothermic reaction, and we're going to define bond energy. We're going to discuss the enthalpy, define activation energy and the activated complex, and discuss the potential energy. Okay, so that is what we are going to be doing today. Okay, just trying to move. So energy changes. What are energy changes? Whenever a chemical reaction takes place, there's always a change in energy of the system. An exothermic reaction is a reaction that results in the system becoming hotter. The heat is given to the surrounding area. So for example, when we have CH4 and we combine it with O2, it will give us CO2 plus the 2H2O plus energy. So this one is what shows that this is an exothermic reaction because energy is being released. So in an endothermic reaction, alternatively, it's a reaction that results in the system becoming colder. Heat is taken from the surrounding. So this one absorbs energy, and then exothermic releases energy. So for example, with this one, we're going to have the CO2 plus H2O plus the energy, and that is going to give us our product. Okay. And then we come to the enthalpy. The enthalpy, which is a triangle, which is an H, is the total amount of chemical potential energy in a chemical system. So during a chemical reaction, the enthalpy of the system changes. So we know that energy, sorry about that, is required to, to do a chemical reaction. So that's why we have enthalpy, and it's going to change in the different stages. So the change in enthalpy is given with a symbol of a triangle H. For an exothermic reaction, the triangle H, which is the change in enthalpy, is negative, and for the endothermic reaction, the change in enthalpy will be greater than 0, which means basically it will be a positive. Okay. So what is bond energy? Okay. So during a chemical reaction, bonds are broken by energy being taken in, and new bonds are formed, resulting in energy being given off. So the energy which is absorbed when bonds are broken or released when new bonds are formed is known as bond energy. What are bond energy, guys? Bond energy, for example, here, you can see that here we've got a CH4 and here we've got an O2. So what they talk about when they talk about bond energy, it means that between the carbon and the hydrogen, there are bonds that are there that put these chemicals together. So they are the ones that are called our bond energy. So in order for a reaction to take place and a product to be formed, these bonds sometimes have to be broken down and new ones need to be formed. As you can see here, it was CH4. Now we've got CO2 and H2O because the bonds, they break and they form new bonds to make a new product. Okay, so here we've got a table of bond energies. This table of bond energies, it shows basically the bonds that can be formed and the energy that is there that is putting the bonds together. So for H2, we know that 432 is going to be the bond energy, but we also have others. We've got HO, we've got fluorine, we've got chlorine, and we've got a whole system of bonds that have different bond energy. You can see even others, they've got double bonds, others are single bonds, others are triple bonds. So that is all bond energies that hold the chemicals together. So now we're going to move on to our potential energy diagrams. Why do we have a potential energy diagram, guys? We are doing this potential energy diagram in order for us to distinguish between our two chemical reactions, which is our exothermic reaction and our endothermic reaction. So if you look into the exothermic reaction, you can see that these two tables are not the same, okay? So you can see that here, the reactants are much higher than the product, okay? Can you see that? So if this was, for example, the energy diagram for exothermic, we have our reactants and the activated complex and the product formed. You guys can see that between the reactants and the product, there's a chemical reaction that takes place. So different chemical reactions take place that we are going to explain in this lesson in order for you guys to understand, so that this product gets to be formed. So also on an endothermic, you guys can see that you've got our reactants, but we've got our product, which has a higher potential energy than our reactants, and our potential energy for exothermic is higher than the potential energy on our product side. Okay, so you can just see the difference. So guys, you need to be able to draw these graphs, because these are some of the things that are going to be asked in the exam, okay, or the test. They can ask you to draw the potential energy diagram, okay? So what do we know? We already know a couple of things so far, is that the change in enthalpy is equals to the heat of the product, minus the heat of the reactant. That's why it's got a triangle, because it's a change. Anything that says change, you know that it's a minus. You're finding the difference between two variables, which in this case is going to be our heat. So in what we know about the exothermic is that if this one, you guys remember I mentioned that on an exothermic, the potential energy is higher on your reactants than it is on your product. So if your product is lower than your heat, if your product is lower than your reactants, automatically the change in H is going to be a minus, because minus, like 4, let's say this one is 5 and this one is 2, because it's lower, right? So if you're going to say 2 minus 5, it's going to give us a negative answer. So that's what they try to explain here. So you guys can just always remember that exothermic is always, the heat is always less than 0. It's always a negative. But when you come here and look at the endothermic reaction, you'll see that the potential energy of the product is higher than the potential energy of the reactant. So which means that this will always give us a positive answer, because when you say the product minus the reactant, we're going to have a positive answer, because this one is always higher than the reactant. So in an endothermic reaction, the heat is always greater than 1. Okay. So now we come to the other things, the equations, on how our equations are going to be written out. Our reactants will always be the product plus energy. Why do we have energy this side? Because in an exothermic reaction, energy is being released. Remember, we spoke about that. And on an endothermic reaction, it's going to be reactants plus energy, because energy is being absorbed in order to form our product. Okay. So I hope that this makes sense, but we're still going to talk more about it. So that's why we got I got you guys this diagram just to illustrate to you guys that in an endothermic reaction, heat is being taken in, and on an exothermic, it's been given out. So all the like here, your water stores all the cold and it becomes compacted and it forms an ice. So this is an endothermic reaction. But in this case, you light your match and heat is released. And this is our exothermic reaction. Guys, if you have questions, please don't be afraid and do ask on the chat. So now we come to the endothermic versus sorry about this. It's endothermic versus exothermic energy. Okay, so I made a table for us to be able to see the difference. So it says here in an endothermic reactions are chemical reactions that absorb heat from the surrounding. Exothermic are chemical reactions that release heat from the to the surrounding. The temperature decreases with progression of the reaction. So the temperature will always become less as a reaction takes place. But for an exothermic reaction, the temperature will increase with the progression of the reaction. For example, guys, you know when you light a fire and the temperature keeps increasing and the fire keeps getting high. So basically, that's what it means. So the enthalpy of reactant is lower than that of the product. So which means that our enthalpy is lower than that of the products, like we already showed it on the graph. But on the enthalpy side for the exothermic, the enthalpy of reactants is higher than that of products. So the change in enthalpy H, sorry, here it's supposed to have a triangle because it's a triangle H, is a positive value. And the change in enthalpy for exothermic is a negative value. So energy should be given to the system and energy is released from the system. So for an endothermic reaction, in the beginning, the system's enthalpy equals the total of the reactant's enthalpies. So because of these energy absorption, the enthalpy or energy of the product is higher at the end of the endothermic reaction. So this can be explained as such. So let's say we've got these two, A and B is going to be our reactants, C and D is going to be our product. So we're going to say that A plus B will give us C and D. So when we try and transfigure it into the enthalpy part, we're going to say change in enthalpy is going to be the product minus the reactants. So the product in this case is going to be our HC and our HD, and we're going to minus that with our HA plus HB. So these two, you add them together and you add those together and you get the difference of the two. Okay, so change in H will be the product minus the reactants, and this will give you a positive value because our product has a higher enthalpy than our reactants. So these are some of the examples that we can get of endothermic energy. Dissolving ammonium chloride in water. So what we'll have there, you're going to have an equation of this nature, but it's got the heat added to it and it gives you a product. So like I mentioned to you guys, every time you see an equation, where a chemical equation where there's heat, where they say plus heat, then you know that it's on your reactant side, then you know that this is a endothermic reaction. So we also have a reacting ethanoic acid with sodium carbonate, and this one is a much longer one. But as you can see here, we also have the heat added on the reactant side. So note that the heat is included in the right side of the reaction equation. This is to indicate the absorption of heat by the system. Okay. So for an exothermic reaction, it's going to be quite different. Let's say P plus Q will give us R plus S. If this is the case, then our change in H is going to be our product minus our reactant. But what's the trick with the exothermic reaction? with the exothermic energy, it's that our reactant is much higher than our product. Okay, so our reactant is higher than the product. So if you're going to say 2 minus 5, it's going to give us a negative answer, and this will be a negative enthalpy, and that is our exothermic reaction. So burning of hydrogen gas is an example of exothermic reaction, because we've got our two elements here, but they release heat. So we've got heat on the product side. So your heat is always on the product side when you're doing an exothermic reaction. So what's the difference between the endothermic and the exothermic reactions? We have mentioned most of it. I think what we also need to take note of from what we've explained. Okay, we said with the endothermic, when we on the definition side, the endothermic takes in heat, absorbs heat, and exothermic reaction releases heat to the surroundings. But when it comes to the temperature, the endothermic reaction, it decreases with the progression of the reaction, but with exothermic, it increases temperature with the progression of the reaction. And then when we get to our enthalpy on an endothermic reaction is lower than the product in the endothermic reaction. And on our exothermic reactions, the reactants are higher than the products. Okay, so you see the whole changing, the differences. They both have, they basically almost work in opposite of each other. So what about the change in enthalpy? We know that for an endothermic, the change in enthalpy will always be a positive, but for an exothermic reaction, the change in enthalpy will always be a negative. And what about the energy? When we get to the energy, we know that in endothermic energy, in an endothermic reaction, energy should be given to the system in endothermic reactions, and exothermic energy is released to the system. Okay, just like we showed the ice and the fire to demonstrate how they work on opposite ways. Now, we are going to move to the catalyst. What is a catalyst, guys? I know that you guys might have seen or heard, a catalyst is something that makes something go faster or go at a higher rate. So in our in chemistry, a catalyst can increase the rate of reaction without being consumed by the reaction or taking part in the reaction. A catalyst lowers the activation energy, but does not change the change in enthalpy of the reaction. Just to explain this a little bit to you guys, what does it mean when they say it increases the rate of reaction without taking part? I mean, if it's part of the reaction, why is it not changing anything? What the catalyst does basically, if this is your diagram, you've got your reactants and they go all the way up to your activated complex with your activation energy and go all the way to your product. So what a catalyst does, it just reduces the time. So it speeds up the reaction. Okay, so it makes it faster, but it'll still yield the same product, but only at a quicker rate. So basically, it makes it faster so that your reaction can take place faster. So that's what a catalyst does. It just lowers the activation energy, because if you can lower the activation energy, then your reaction can take place on a much quicker rate. So still on the activation, and now we're going to move on. We're done with the catalyst. We're going to talk about our activation energy. What is our activation energy? Activation energy is the minimum amount of energy that is needed to start a chemical reaction. Okay. The minimum amount needed to start a chemical reaction. So you've got your two products here. You've got your two reactants here, and you want to make your product, which is on this side. So what in this part, just looking at these two, the product and reactants, the activation energy is basically what you need, the amount of energy that you will need for your reaction to take place. Okay. So when you look at your activation energy, you can see that you start with these ones, and then they come all the way up to your activated complex. What happens when it gets to your activated complex? Your molecules, they collide with each other. They collide, and start to form new bonds. And by the time they reach the end of the reaction, then your new bonds are formed as products. Okay, so that's what your activation energy does. It's basically in the activated complex, the bonds are broken up and new bonds are formed. So it's breaking up of bonds and forming of new bonds, breaking up of reactants and forming of products. Okay, I hope that it all makes sense. Then let's go to the activated complex now. Okay, we've spoken about our reactants, we've spoken about our products, and now we spoke about the activation energy, which is the energy required for a reaction to take place. And then on top there, while it goes up, the reaction will start all the way up using activation energy. And on the activated complex, you see all the bonds are broken up. Now we've got H and H, F and F. We don't have H2 and F2 anymore. So these bonds are broken down, and now they start to form a new bond, which is going to be our 2HF. Okay. I hope it all makes sense to you guys as we try and break it down accordingly. So the activated complex or transition state is what it's termed. It's termed, you can also say it's an activated complex or a transition state. The activated compound is only active for a brief period. So which means that the breaking of reactants and forming of product happens very quickly. It's not something that takes time. It has to happen very quickly as they collide. They collide on each other, they break, and they form new bonds. After this brief period, one of two things happen. The original bonds will reform, or bonds will be broken, resulting in the formation of new products. So the ultimate product in this case was our hydrogen fluorine, okay, which has a lower energy than the reactants. So you can see here. So this one is obviously an endothermic, exothermic reaction, right? Because we can see that the product is lower than the reactant. The potential energy on your product is lower than your potential energy on your reactant. So the ultimate product, which is lower energy than the reactant. So minus H is a negative reaction, and this we all already know it's an exothermic reaction. Okay. So guys, I hope that all of this is slowly starting to make sense. I just wanted to check on our Siyavula textbook. I know there was a bit of some examples there that I wanted you guys to look through. Okay. Okay. Okay, you guys know we work mostly with our Siyavula textbook because it's standard for everyone. It's free to download and it's also CAPS approved, okay? So I just wanted us to look through some of the problems. Okay. So here's something that I also wanted us to get through that we should also know is that some of the names of the, there are many examples of endothermic and exothermic reactions that occur around us all the time. So these are some of the few examples. So a photosynthesis reaction is an example of a endothermic reaction. So these are questions that can be asked that name the types of endothermic reactions that can take place. So we know that we'll have photosynthesis and the decomposition, okay, of limestone. So photosynthesis is a chemical reaction that takes place in green plant, which uses energy from the sun. So you guys see what it means. It's a plant, it absorbs heat from the sun, and it changes the carbon dioxide and water into food that the plant needs to survive. So basically, it means that without the sun or some sort of heat energy, because these days, with technology enhancements, they can even do that without the sun. They can just build all these plant houses, and they know how to um, generate the heat that a normal plant would get from the sun. Okay, and that's how our plants survive, and which other organisms can eat, and they can too also survive using it. So this is an example of a endothermic reaction. Okay, you can see that it's carbon dioxide, water, and it also needs energy. In this case, it would be the sun, and it would give us our glucose and oxygen. Okay, so photosynthesis is an endothermic reaction. Energy in the form of sunlight is absorbed in the reaction. Okay, so always when it comes to absorbing, we're talking about endothermic reaction. And for thermal decomposition of limestone, so here, this is an industry example. The breakdown of limestone into quicklime and carbon dioxide is very important. Quicklime can be used to make steel from iron and also neutralize soils that are too acidic. So, however, the limestone must be heated in the oven at a temperature before decomposing reaction can take place. So the equation would also be one way it's this plus the heat from the oven, if we can put it, or the kiln, and then this will give us our product, which is what we are looking for. Okay, and then our exothermic reaction also has two types of reactions as well. Okay, so we know that in exothermic reaction we are giving off heat. So the first example, the first type of exothermic reaction would be our combustion. The burning of fuel is a combustion reaction. Anything, the minute you get a question that talks about burning, you know that they are talking about combustion reaction. So that will always be an exothermic, because heat is given or fire comes out as a result. As we humans rely heavily on this process for our requirements, the following equation describes the combustion of hydrocarbons such as petrol. Okay, so here you can see you've got fuel, you've got oxygen, and this, it gives you heat. So this also, guys, can be things like explosions. All of those are exothermic reactions because they give out heat. Okay, so that is why we burn fuels for energy, because the chemical changes that take place during the reaction releases huge amount of energy. Okay, so it's always the result of a combustion reaction will always be carbon dioxide, water, and heat. Okay, so these are just small little things that you can look for whenever you analyze your questions that are given to you. And then the other one is a respiration. What is respiration? Respiration is a chemical reaction that happens in our bodies, which means this one is internal, okay, on how our bodies to produce energy for our cells. The equation below describes what happens during this reaction. So we're going to have our glucose plus our oxygen, and it's going to give us our carbon dioxide plus water plus energy. So in this reaction above, glucose reacts with oxygen from the air that we breathe in to form our carbon dioxide. Okay. So those are the examples of examples of our endothermic and exothermic reactions. Okay. So there is some questions that you guys can also go into, and I hope that everything makes sense so far on how we work out I hope everybody now understands what is exothermic reaction, what is endothermic reaction, what's the difference between them, what are their characteristics as well, and what is the reason we have them. So those are two important things that we always have to take note of. So I just want us to go to a problem. So this one is things that we've already explained. I want us to go to some of our problems because I know they have good problems here on the Siavula textbook. Okay, so basically, I'm just looking for an example. Oh God, now I'm moving too far. Oh, now I'm calling. Okay, sorry about that, guys. So, guys, you will have questions where you have to find what is the enthalpy, find what is a chemical react, what kind of reaction are you dealing with, and those. I'm just struggling to get to the problems at play right now. So one. Okay, here we are. So we've spoken about the different types of energies, the bonds. Okay. Okay, so let's look into this one. So I see we don't have an actual example. So it says here, state whether energy is taken in or released in each of the following situation. So we're going to start with the first one. It says the bond between hydrogen and chlorine in a molecule of the bond between hydrogen and chlorine in a molecule of hydrogen chlorine. So what kind of is the energy taken in, or is the energy being released? So here I think the bonds between hydrogen and chlorine in a molecule of hydrogen chloride breaks. We would need to take in energy in order to break the bonds. Okay. Okay, does that make sense? The bond is formed between hydrogen and fluorine to form a molecule of hydrogen fluoride. So this is more like of a releasing. Okay, energy is being released. A molecule of nitrogen is formed. So N plus N will give us nitrogen, and in here energy will be released as well. So a molecule of carbon breaks apart. So this one, we take in energy in order to release, to break the bonds and have a different kind of molecule. So this one, it's taking in, and number C is release. So state whether the following description is used to describe an endothermic or exothermic reaction. Okay, so let's start with the first one. It says here reactants react to give product and energy. So here we've got our R arrow gives you product and energy. What do we know this as? This is our exothermic reaction because our energy is in the product side. Okay, does it make sense? So it says here the energy that must be absorbed to break the bonds in the reactants is greater than the energy that is released when the product is formed. The energy that must be absorbed is greater than the energy that is released when the product is formed. So this would be our endothermic reaction, right? So the energy of the product is found to be greater than the energy of the reactants. The energy of the product is greater than the energy of the reaction. So this is our this is our endothermic reaction. Heat or light must be absorbed from the surrounding before this type of reaction takes place. So this one is obvious. This will be our endothermic because it talks about absorption of heat or light. Okay. So guys, thank you guys so much for this classroom. I hope that you guys can do some of these exercises as well, just to, just to familiarize yourself with endothermic and exothermic reactions, because these things are going to be required, okay? Are going to be required for your exam. So can you guys please make sure that you understand the work? And just going back to, grade 11 and in this time of the COVID-19 problems, yeah, guys, it's been really tough. And I know that the pressure is not just on, the environment alone, but you guys as the students, you guys are struggling more because each and every year you come to a new subject and there's new things that you have to learn. So um, I hope that you guys, you continue to work hard and try your best so that you can be able to apply for your grade 12, and you can also start applying for university using your grade 11 marks. So the only best way to do this is by making sure that you understand the work so that you can be capable of writing your examination. And I'm wishing you guys all the best in that. And guys, if you guys feel like you're having problems, like it's becoming too much pressure for you guys to do your work or even concentrate, guys, please just get into our inboxes and send me an email. It's t33t ndlovu@gmail.com. You can contact me there, and you can just talk about it, and we can see how we can assist you, because there's a lot of peer supports and there's also a lot of mentorships that assist, because we don't want any student going to the end of the year because of with depression and being unable to pass because they couldn't handle the pressure. Always make sure, guys, you drink a lot of water, you rest, you exercise, and you study in time. Don't study too much before the day, but study consecutively. It's always great as well to always have a timetable of how you're gonna do your work. For example, maybe Monday for 1 hour you're doing maths, the next hour you're doing physical sciences. That is very good, guys. You guys need to push, because at the end of the day, how you operate now is going to define how you're going to be operating, even when you get to university, because you need to always be able to work on a particular pattern in order for you to complete your work. So guys, I really encourage you guys to go through the work and study hard, guys. Not study smart and not hard. Make sure that you understand everything. Always have diagrams that show the differences. For example, if you're doing your endothermic and exothermic, it's always great to draw graphs and to draw tables, and showing the difference between the two, being able to explain by using colors, and doing different points in order for you to be able to understand what you are doing. But nonetheless, guys, this is a summary of everything. When a reaction takes place, when a reaction occurs, bonds in the reactants break and new bonds in the product forms. These changes involve energy. When bonds break, energy is absorbed, and when new bonds form, energy is released. The bond energy is a measure of bond strength in a chemical bond. It is the amount of energy in kilojoules per mole that is needed to break the chemical bond between two atoms. So the enthalpy is a measure of the total energy of a chemical system for a given pressure, and it's always given by the symbol of H. Okay, guys. Thank you guys for joining me in this classroom. And Our time is up. I hope that you guys are going to have a great day. And please, guys, do shout out where you're struggling, even if it's other sections of physical sciences. Please let me know. Slide into my inboxes, and we can work it out and see how we get through it. Thank you, guys, and goodbye.